In 1983, the MSX standard aimed to bring software and hardware compatibility to home computers from different manufacturers. But with over 20 companies making MSX machines, how did any one stand out? And how, for a standard that required a Z80 CPU and a video chip from the 1970s, was this Palcom PX7 able to offer full motion video gaming over 40 years ago? Let's find out together, as on today's Retro Tech Repair, I try to fix this very special MSX that I bought spares or repair on eBay. And as we take a look around this MSX, I need to start with an apology. Unfortunately, I had problems with the audio when I recorded the original video, so this video has a bit more voiceover than I usually like to have. But I am going to leave the clipped audio in place for some segments, because I think it's important that you see things just as they happened, and that without that, you might not believe that they happened just as they did. Let's start then by looking at the keyboard. It's got quite a nice action, not the very best, but certainly a premium feel. To the right we have the usual cursor keys, and to the left 4 function keys, labelled Video, Computer, Superimpose and Select, and perhaps the first hint as to what makes this particular MSX so special. Looking then at the front of the unit, and I'm taken by just how handsome it is. It looks more like a piece of modern hi-fi equipment than it does a computer from the 1980s. There's no beige plastic here. Instead we have crisply folded steel painted satin black, a brushed satin power switch together with the keyboard connector, 2 joystick ports, even a headphone socket and some audio sliders. In fact, I recently showed the computer at RetroFest 2025, and there were plenty of people there who perhaps didn't know what it was, mistaking it for a more modern machine than a 1985 MSX. One thing that does give away its heritage is the absence of any disk drives and the presence of a cartridge slot. This is one of 2 cartridge slots on the machine, the second one being located on the rear. Looking at the rear of the unit then, and we have a parallel printer port, a cassette port, a panel labelled System Control with 4 connectors in it, an RGB out, UHF out, video out and video in, and stereo audio out and audio in. This machine then is designed to be used with a Pioneer Laserdisc player for interactive entertainment or education. The video input, output and graphics can also be used for video titling and editing, and the keys that we saw on the left of the keyboard are used to select the computer's video output to be either the video signal that's been fed into it, the output from the computer itself, or the video output from the computer itself superimposed on that incoming video signal. Before we can explore any of this though, we need to make sure the computer works. So let's get it hooked up to a television and powered on. And of course it didn't work and no analog signals were found. The television just picked up the digital signals that were being broadcast at that time. Although it did get really, really hot. We better take a look inside and see what's going on. Looking inside then, and it looks like this machine has saved the beige for its printed circuit boards. There are 2 main PCBs inside the unit. The upper one that you can see now looks distinctly analog in its nature, and the almost identically sized board beneath it contains the digital circuitry and is a more conventional colour of green. There are a few other small printed circuit boards in the machine too. These are connected to the front panel and hold things like the joystick ports. There is one large IC on this board, but I wasn't able to ascertain what it is. It's Pioneer branded, but a search of the part number didn't yield anything useful. The power supply is a fairly conventional affair, with a transformer, bridge rectifier, and linear regulators for 5 volts and 12 volts. The large 5 volt regulator and the 12 volt regulator are both mounted to a common heatsink, which connects to a large bar which goes across the full width of the chassis of the machine. In addition to the large integrated circuit, the top board has a number of other active components, as well as a lot of electrolytic capacitors, although I didn't see anything bulging or leaking. The first thing that I chose to do then was to check for shorts between the 5 volt line, 12 volt line and ground. So just connecting to the heatsink here, I'm sure one of these pins connects to that. It's not the left-hand side one. It doesn't appear to be the right-hand side one either, which is promising. It's over the center. Very good. So there's no short between the center pin and either of the outside pins. Let's just see if those two are shorted together. No. So we don't seem to have a short on the 12 volt. And with no short on the 12 volt line, I turn my attention to the 5. So it's a little bit difficult for me to position this so that you can see it, but looking at this 5 volt regulator here, we have the input on the left hand side, the output on the middle pin, and the ground on the right hand pin, at least from the angle that I am looking at it right now. Let me just check continuity between the heatsink and the ground, which should be this pin over here. That's good, that's the right hand pin. And then we'll check it to the left hand pin, which is labelled on the silk screen as the input. Yeah, that looks to be okay. And then we'll look at the output, which is the centre pin. So that's between the centre pin and the heatsink, which is supposed to be ground. Yeah, it looks like we have a short between 5 volts and ground. So that would explain why nothing's working in here. What it doesn't do, though, is really pinpoint where that is, because I'm guessing that there's quite a lot of these caps are between 5 volt and ground. Let's see if we can find a TTL chip or something on here. Something we know the pin out of, just to confirm that. Here we go, we've got a 74LS05N. So we'll go between the ground and the 5 volts on that. Yeah, dead short. So dead short on the 5 volt line, but where it is, who knows? Could be one of these capacitors that's gone short, could be this regulator itself, or I suppose it could be something else. So we'll dig into that and see. First thing we have to do, though, is disassemble some of this, which looks like it's going to be quite tricky. So now I have to try and find out where the short is between ground and 5 volts. And there are an awful lot of components in this computer which could be causing that short. So I decided to try removing things from the upper main board that we see here to try and find out whether the fault is on that board or on one of the boards that it's connected to. So now I have the ground of the voltage regulator via the heatsink connected to my meter, the negative probe here, and then the positive probe is connected to the output of this voltage regulator here, and that's directly to my meter. So when I turn this on and put it into continuity test, we should have a constant beep, which we do. And now if I remove these connectors from the board, we'll see if that improves our 5 volt short situation. I'll do the smaller one first. No. Oh yes, that was it. That was it. Wow. So is that only short on this J32? Huh. That's interesting. I wonder where that goes. Well, we'll just reconnect again, see if the short comes back. Yes, it does. Huh. Wasn't that lucky? Alright. Well, with that all connected then, let's see if we power this up, if we get 5 volts on here. Tell you what, I don't know if I measured that before, so let's put this back in. Turn it off briefly. We probably shouldn't do this, but it's already been through this trauma before. So that's back in. Now we have that short. Yeah. We'll leave this on a voltage measurement. We'll leave it off. We'll briefly power it up. And it's probably going to be a few millivolts here. Yeah, it's a few millivolts. And then as we remove this, it should go up to 5 volts. Yes, yes. So whatever's shorting out our 5 volt line is at the end of this connector. So I just took a quick look at the circuit diagram, and this connector which goes in here, which was causing our 5 volt short, is just that. It's just the power supply to this amplifier board. Just off camera, let me zoom out a bit so we can see that. So this amplifier board here is powered by a 5-volt supply, and this is the 5-volt supply to it. Got the probes connected back up now, and we'll just go, I guess, across these wires. One of them, I think 2 of them are grounded, one of them's 5 volts. Short, short, yeah. And then on the board here, these go to ground here, and then this one goes to 5 volts. Yeah, so there's a short on this subboard here. So we need to go ahead and get that subboard removed. A handful of screws and a little bit of jiggling is required to remove the front cover, and then just one screw holds the board that's of interest to us to the front of the enclosure. Well, that's certainly loose. That might just do it. Let's see if we can maneuver this around, and we can. Fantastic. And take a look at the connectors here. So looking closely at this amplifier board then, and there isn't really a whole lot going on. Connectors come off here to the speakers. There's a fixed wire to some volume controls on the front for the left and right channel. This is where our power comes in. There's 2 amplifier chips, which probably are the ones that I suspect are the most likely cause of our short, at least one of them, perhaps if not both. And then a bunch of passive components, and really not much else. Looking at the path that our 5 volts takes, or rather doesn't take, it comes in on this cable here. 2 of those go to what I think is ground. That ground is then kind of carried around the board, including to this amplifier IC here, and then on the track to this amplifier IC here, and to the speakers and a bunch of other places. And then the 5 volts comes in here. There's one cap across here between ground and 5 volts, which obviously could have gone short, although I don't see any damage to it. And then the 5 volt goes from this jumper here out again to our 2 amplifier chips. So possibilities are a shorted amplifier, one or the other or both, a shorted cable, or a shorted cap here. My guess, again, as I say, is probably on one or both of these 2 amplifiers, probably one, but it would be easier for me to remove a leg off one of these caps and just check that that is not the cause of the problem, and also to remove one of the cable connectors to make sure that isn't too. So I'll probably do those 2 things first. This is the ground tab, so it's going to need a little bit more kind of heat going into it as it's absorbed by the track, but I think that got it. And my guessing is that this part is fine and we've still got a dead short between ground and 5 volts, but we'll leave it out anyhow. But for now, let's test it. Let's find out. So with our meter on continuity test, let's test to see if we have a dead short still between 5 volts and ground on this board. No, we don't. Could that be it then? Has this cap gone dead short? Yes. Yes, it has. Well, look at that. So it looks then like a single electrolytic capacitor was the cause of a dead short on our 5 volt line. And I'm shocked at just how lucky I got. The 5 volt line was one of the first things that I tested. The first thing that I did to try and find the short was to pull cables. The first cable that I pulled was the one that had the short. And the first component that I tested on the board on the end of that cable was the capacitor that was causing the short on the board. You'd be right to be a little bit skeptical, but trust me, this is exactly how it happened. So looking at that part then, and there's no visual indication that it's failed at all. There's no discoloration, no bulging, no burning, no leaking, nothing. It looks fine. The only way to determine there is anything wrong with it at all is to test it electrically. And when we do that, we can see that the component tester thinks it's a low-value resistor. As luck would have it, I've got quite a few 1000 microfarad caps, but they're all significantly taller than the one that was on the board, and height will be a little bit of an issue in that particular spot. But a rummage around found just one more that is just a little bit taller than the one that was originally in the board, and has a higher temperature rating and a higher voltage rating. So we'll go ahead and solder that one in. Okay, and that should be it. And we'll check across that 5 volts now to see if we have continuity or whether we now are clear and have no DC path. And in fact, that looks to be good too. So we no longer have a dead short between the 5 volts and the 2 ground conductors in this cable. So let's connect it back to the printed circuit board and see if the computer works. And fantastic, it is working. And the whole system was brought down by just one faulty capacitor on a 5 volt line on an audio board. So I'm curious to know why our little capacitor here failed. So I've connected my oscilloscope onto the output of the 5 volt voltage regulator, and looking at that, and I don't know whether I'm measuring it right or not to be honest, but I'm seeing about 50 millivolts peak to peak, which I think, from what I know, is not unreasonable for noise on a 5 volt line out of a kind of linear regulator like this. The circuit diagram shows 2 capacitors which are across the 5 volt line. This one, which is prior to voltage regulation, and this one, which is after it. Now, looking at these two individually, this one is rated at 16 volts, and this one is rated at 25. Our little cap here is rated only at 6.3. So my theory is that this capacitor rated at 6.3 volts was just running too close to its rated value on the 5 volt line. This is good news because the one I replaced it with is rated at 16 volts. So the replacement cap was all that was needed to get our MSX up and running. And it's been running now for about 72 hours on a soak test, and it's doing everything that we would expect an MSX to be able to do. But as well as those Japanese games that made the entire MSX series famous, what can our particular MSX do? Well, there's this. So all that's going on here, of course, is that our Palcom PX7 is overlaying its own video output on top of a PAL video signal that's been input via the connectors on the rear of the unit that we saw earlier in the video. In this case, from an attached media player. Now, unfortunately, our computer has no control over that media player, but what if it was connected to a Laserdisc? After all, it does have a custom interface designed to control such a player. However, there are a number of problems. All of the games that were made are in NTSC format, and this is a PAL, Palcom PX7. Perhaps even more significantly, I have 2 such players. They're quite expensive and neither of them work. Okay, and we'll press play. And it immediately ejects it. These issues, therefore, will be subject to a future video. And for today, all I have to offer you is emulation. Now, I am determined that one day I will play games on this PX7 from a Laserdisc via a Laserdisc player. But for today at least, this does just about wrap it up for our Palcom PX7. Just before we go though, I wanted to give a quick shout out to a very special subscriber, Augie or August from the Netherlands. I hope that you enjoyed the video today, and I hope that everybody else did too. And until next time then, I'd just like to thank you all for watching RetroTech Repair. Now the play. Oops. And back. And off we come with the lid.